Maybe we shall start, so not to waste time and other people will join. So dear colleagues, dear participants of our conference, it is my great pleasure and honor to moderate our today's section and to introduce the first team of speakers, Rahim Mammadov, Timur Aliyev, and Gurban Mammadov, and their presentation, Minimization of the Average Risk in Pattern Recognition for Smart Grid System. Okay, so you're welcome.
Yes, okay, thanks. Good afternoon. My name is Timur Aliyev. I'm Associate Professor of Instrument Engineering Department of Azerbaijan State or Industry University. And our team prepares a report on the topic, minimization of average risk in pattern recognition for the smart grid system. Okay, let's start. In the development of the principle of the invariant pattern recognition, each object can be represented in the form XE. A standard pattern can be represented in the form Y. The value of the proximity measure between the partners, or the PMBP, evaluated indirectly by the if parameters, can be determined by the expression 1. As full invariance of pattern recognition is reached, the desired value of ZE is specified by the expression 2. To determine condition ZE equals ZE1, form 1 or on rearrangement can be expanded into the Taylor series. Taking linear terms, we can derive the condition of invariance of the PMBP value with respect to the stabilizing factors 3. The assertion of pattern recognition in this case can be read as a sum of the independent uncorrelated events characterizing the errors of measurements of parameter values of the checked and started object. Consequently, the certainty of the pattern recognition can be determined as a product of the fiducial probabilities of parameters of value measurements of the both objects. The artist certain of the technical visual system will be allows less than the separate fiducial probabilities of the measurement of parameters X and Y. To increase the certainty, it is necessary to decrease the error of the measurement of these parameters. Through the development of effective methods for the correction of the measurement errors of images parameters of nature object is a real problem. That I use representative of mathematical method for the PMBP estimation in the implicit form, which is represented by the expression 10. We can see from the 10 that the stabilizing factors affect the parameter X and Y identically. Therefore, by minimizing those influences, we can increase the information body of the PMBP value. In order to determine extreme points, we expand 10 into the Taylor series and then only consider linear terms. On some transformation, we can find the condition of invariance of PMBP estimation for the stabilizing factors alone. Condition 11 shows that to minimize the influences of the stabilizing factors for the PMBP values, it is necessary to minimize those influences on each parameters X and Y, and the sum of influences of the parameters should be minimal. Next, to develop the method for minimizing of estimation errors of PMBP, we analyze the composition of the distribution laws for the measurement errors of the parameters of the recognized and reference images. Suppose the probability density Px and Py of the values of the input and reference features X and Y have an arbitrary form, and the errors gamma X and gamma Y is superimposed on the values X and Y are determined according to the normal value Mx and Mx, Mx and My, gamma X and gamma Y. It is assumed that the errors gamma X and gamma Y are correlated but independent of the value X. If the values of the X and Y differ by the value Z, which equals Z equals 0 minus X minus Y, an error of the first and second general. As is now the problems of control and recognition, each error has its own cost, alpha and beta, which take on non-negative values. In this case, the average risk C will be equal to the mathematical expectation of the cost, which is presented by the expression 14. It is necessary to find the difference between the values of x and y, which correspond to the values of the pattern recognition system or signal. For this, computation of two normal laws of probability density with respect of the variable gamma x minus gamma y equals gamma z is completed by the expression 15. Using the variable gamma z, the condition of the occurrence of errors of the first and second kind can be represented as x more than the y and x minus y equal and less than the y minus z is the first. Second is the x equal and less than the y and x minus y more than the y minus z. Considering the dominance of the definition of probabilities PA and PB is represented by the expression 16. The value of output signal should be determined by the minimum average risk. For this, we differentiate the last form and equate to 0. The solution to this equation gives the desired value of the z in genuine form. Since the exact value of the z is determined by the computational operation, we will approximate determine it. By the mean value theorem, the transform form in the expression 17. The exact value of the z is determined by the Simpson's method using the following algorithm, which is represented by the expression 25. The initial value of z is taken to the end of the range x minimum to the x maximum, and it is represented by the expression 26. With a more simplified definition of the value of z, it is required that the condition be met like the expression 28 or 27. The accepted receptions allows alpha 1 and beta 1 to be replaced by alpha and beta in form of 17 is represented by the expression 30. Approximate 30 becomes strict if the fx equals a constant in the range n sigma 0 or even more so in the entire range of the x. The equation 30 is changed as presented by the expression 31. The form of 31, the Laplace function are tabulated due to the fact that the x maximum minus y plus z minus m0 more than the 3 sigma 0 and the x minimum minus x plus z minus m0 more than the 3 sigma 0. The first Laplace function is equal to 1 and fourth is equal to 0. Consequently, we get the expression 32. With the ability of the creation of either observed when the alpha equals the beta, the z parameter can be determined by determined only by parameters mx and my. Z will be equal to mx minus my. Because fk equals 0.5 with the k equals 0. More fixated treatment in this process allows you to propose a condition for providing the invariance of the PMBB values. For random errors, we get the expression 32 or 34, and for systematic errors, we get expression 35. To test the proposed method of increasing the reliability of the pattern recognition, computer modeling was performed. The input images in the form of the certain shape and its parameters are selected. For comparison, standard object similar to the input image was adopted and its parameters were also measured in accordance with the proposed method. After that, using the standard formulas of estimating the measure of the proximity between the objects, for example, Manhattan equation, Canberra equation, the main parameters of the measure of the proximity between the objects are determined. The simulation results shown in this table 1. In addition, by using the set of different images, an array of data of the assessment of the measure proximity between the object was obtained as a regression model of the dependence between the main parameters of the assessment of the measure of proximity between the object were constructed. Regression model are shown in the table 2. The constructed models and table show the efficacy of the proposed method for increasing the accuracy of estimating the measure of proximity between the objects, and as a result, increases the reliability of the pattern recognition. And in conclusion, I have to say that the application of this proposed method for minimizing the error is assessing the state of the object or the process of the electrical power industry by the SCADA system will improve the reliability and quality of power supply. This is achieved through more accurate diagnostic of the condition of the equipment produced in the real time on the equipment of the power plant, substation, and power lines. Correct analysis will allow you to receive early warning of the possible network failure, establish the causes of the equipment failures, predict the volume and timing of repairs, as well as the equipment service. Truth, it is possible to improve the efficiency of power system, so the stable supply of the electricity of the consumer as reduce the repair cost by reducing the number of the equipment failures. Thank you for your attention. I'm finished.
Yes, thank you very much for your presentation. So, dear colleagues, now your questions.
I have questions.
Yes, please.
For you. Thank you so much. It was global research, and I have a question. How long is the cycle of using your method to get the desired result? How long is the cycle of using your method to get the desired result?
We create the computer modality. How long? I don't can say the exact time how it's spent, because this work starts my supervisor. And it's difficult for me give you answer because he starts this research and I continue his steps.
Thank you. Thank you so much.
Okay, will you please close your presentation?
Okay.
So we can move forward.
1 minute, please.
And dear colleagues, so the Zoom says that in 8 minutes, so we will have the break. I don't know why. So please rejoin when the time expires. So please rejoin with the same link. So and then we will proceed. And we ask so we invite to our Zoom conference. So the next team of participants: Nataliya, Daria Davidenko, Sergei Lipko, and Valeria Shoroch, mastering computer linguistics for the designation of risks in cooperation communication. So if your presentation will be broken, so we will rejoin and proceed.
Good day. It's me. Good day, dear participants of the conference. I want to present your report, Master in Computer Linguistics for the Designation of Risk in Cooperation Communications. The author of the study are Lipko Sergei, Nataliya Vnukova, Shoroch Valeria, and I, Daria Davidenko. Today I will be the main speaker. Colleagues, you had the opportunity to get acquainted with the report and presentation on our topic. I want to focus your attention on the main idea of the work. First, computational linguistic can't and should serve not only its own goals, but also the tasks of the economy. Second, Google's tools for measuring interest in the certain phrases biases on the linguistics features of concept writing can determine a decision about the prospects of business cooperation. And lastly, the linguistic processing of information should be the input for any research in economics. Thank you for your attention. If you have a question for me, I will be gladly answer them. Yeah, коротко, так? So.
Okay, we have 6 minutes, so we may engage in the discussion. So please ask the speaker the question. So if you have, maybe you can expand your topic. Well,
if I may, I have a question.
Please.
What are the possible applications of your approach? I mean, the minimization.
Repeat, please, your question.
What are the possible applications, practical applications of your approach? Where can we apply your research? I may add, the question was related because I did not really understand smart grid systems. What are they?
We used in our research, we used Google Trends, Google tools, Google Trends, Google Form, hierarchical methods, and other Google tools. Google tools. Why in these instruments we used because Google Trends is a Google service that provides a wide variety of search results, is used to solve this problem. Experience with Google research engineers is progressive and relevant to the change of analyzing user in judgment. The statistic method used by Google Trends provides that it is an effective tools for market research and statistical collections.
Okay, thank you. Now I understood.
Thank you. Nataliya.
Any other questions? So then maybe you can use these 3 minutes for rejoining. Okay, so the time expires. Maybe we can fix it.